Good morning. Today we are going to see about part of speech tagging, an important topic in natural language processing. So in today's class, we are going to cover the definition for POS tagging, what is a tagger, what are the different types of POS tagger, working steps, then why tagging is considered very much vital or important in NLP, the reasons behind, then applications of POS tagging, tools used for POS tagging, and then we are going to see an example, and then the last is challenges. So this is what we are going to see in this session. So first one is about definition for POS tagging. So what is POS tagging? POS tagging is the process of assigning a grammatical category to each word in a sentence. So the definition is very much simple. So POS tagging is the process of assigning grammatically correct category to each word present in a sentence. As you know, in a sentence you may have different words. So these words are all labeled grammatically using POS tagging. Okay, so POS tagging, it is going to assign grammatically correct category to each word in a sentence. Okay, so this is all about the definition. So assigning grammatically correct tag to each word present in a sentence is called POS tagging. So example, so we're going to see the sentence, the cat sat on the mat. How POS tagging assigns labels to each word in this sentence, that's what we are going to see. So first, the word the cat sat on the mat. Okay. So the first word the is labeled as a determiner. The second word cat is labeled as noun. The third word sat is labeled as verb. The fourth word on is labeled as preposition. The next word the is labeled as determiner. And the last word mat is labeled as noun. Okay. So now each word present in the sentence is labeled with its correspondent grammatical category. Okay. So the is labeled as determiner, cat is labeled as noun, sat is labeled as verb, on is labeled as preposition, the is labeled as determiner, mat is labeled as noun. Okay, this is how POS tagging is going to work. Okay, now we are going to see what actually a tagger is. What is a tagger? Now we saw what is all about POS tagging. Now we are going to see what is a tagger. So a tagger is a tool or an algorithm. Okay, so it can be a tool or it can be an algorithm. What it is going to do? This tool automatically assigns this tool automatically assigns correct part of speech to each word present in a sentence based on both okay. So tagger is nothing but a tool or an algorithm. What it is going to do, it is going to assign automatically correct part of speech to each word present in a sentence based on the definition of the word as well as the context where the word is used. Okay, so it's not labeling words just like that. It is going to label based on the definition as well as the context where actually the word is used. Okay, so what does this correct part of speech refer? This correct part of speech refers to either a noun, a pronoun, a verb, adjective, preposition, etc. So it can be any one category of the grammatical structure of a language. Next we are going to see about types of tagger. So there are three types of POS taggers. First one is called rule-based tagger. Rule-based tagger. The second one is called statistical tagger. And the third one is called neural network based tagger. Okay, so there are three types of taggers, namely rule-based tagger, statistical tagger, and then neural network based taggers. So now we are going to see about these three taggers. now we are going to see the types of taggers. So as we know, there are three types of taggers, namely rule-based taggers, statistical taggers, and then neural network-based taggers. So first one, rule-based tagger. So rule-based tagger works based on predefined handwritten rules. Okay, so everything will be written previously, and based on that previously written rules, the tag is or the algorithm is going to work. Okay, so for example, if a word is ending with the suffix ing, it is most likely to be a verb. Okay, so these rules are all written earlier, and based upon these rules, the algorithm or the tagger is going to work. Second category is statistical tagger. So the statistical tagger make use of probability models. So these models are all trained on annotated corpora. So annotated means labeled. Corpora is nothing but a collection of written or spoken text. So there are labeled collection of data, and based on the training given by that data, based on the training taken on the labeled data, the tagger is going to work. Okay, so that is all about statistical tagger. Okay, they use probability models. These models are trained on annotated corpora. Corpora is nothing but collection of written or spoken text. So an example is HMM, hidden Markov model. And the third category is neural network based tagger. So these taggers make use of models like recurrent neural network, long short-term memory, or transformers. So based on these uh, models, the tagger is going to work. So this is all about neural network based taggers. So, okay, so now we till now we saw what actually POS tagging, what is a tagger, and types of tagger. Okay, next we are going to see the working steps of POS tagger. So there are 4 steps in the working of POS tagger. The first step is tokenization. The second step is lexical lookup. The third step is disambiguation. Disambiguation via context. And the fourth step is output generation. Okay. So these are the 4 major steps in the working of a POS tagger. The first step is tokenization. Second step is lexical lookup. Third step is disambiguation via context. And the fourth step is output generation. So now we are going to see in detail about these 4 steps. So first step, tokenization. So in the first step, called tokenization, the input text is split into individual words. Okay. Okay, so the first step, in the first step tokenization, the input text present in the sentence is split into individual words. So now we are going to see an example. So the quick brown fox. This is what the sentence given. So this sentence is split into individual words like so it is split into four individual words, namely the quick brown fox. So this is all about tokenization. So the first step tokenization, the text is split into individual words. So the second step is lexical lookup. So in lexical lookup, the splitted words are all looked up against a lexicon or a vocabulary. Okay. So in the second step, the tokens are all checked against a vocabulary. Okay. So in the first step, the input text is split into individual words. These individual words are called tokens. And the second step, the tokens are all compared against a well-defined vocabulary to determine the correct POS tag. Okay. So this is called lexical lookup. So you are going to check the token against the vocabulary. Why we are going to check the token against the vocabulary? The reason is simple. So to determine the tag. So in order to determine the possible POS tag, the tokens are all checked against the vocabulary. That is the second step, namely lexical lookup. The third step, disambiguation via context. So what does it mean? Disambiguation via context. So in some scenario, a word can have more than one meaning. Take for example, the word book. So the word book can be labeled as a noun or it can be also labeled as a verb depending upon the context where the word is used. So now, in general, if we are saying the word book, it doesn't clearly refers to what, whether it is a noun or it is a verb. So there is a confusion. This is called ambiguity. So this ambiguity is overcome by looking upon the context where the word is used. Okay, so this is called disambiguation via context. So you are overcoming the ambiguity by looking at the context where the word is actually utilized. So many words have multiple POS tags and depending upon the context where the word is used, the tagger resolves the ambiguity. Okay, so it resolves the word by looking upon the context where actually the word is used. And the fourth step is output generation. So here in output generation, each word is paired with the corresponding POS tag. Okay, so the words. So the words are paired with the likely POS tag. So consider the example, the quick brown fox. So there will be labeled as determiner. Quick will be labeled as adjective. Brown is labeled as adjective. Fox is labeled as noun. Okay. So this is how output is generated. So the words or the tokens are all paired with the corresponding tag. Okay. So the is paired with determiner, quick is paired with adjective, brown is labeled or paired with adjective, and fox is labeled with noun. Okay. So this is how POS tagger is working. So there are four major steps in the working. First step is tokenization. Second step is lexical lookup. Third step is disambiguation via context, and the fourth step is output generation. So now we are going to see why this tagging is important. Why tagging is given much importance in natural language processing. So reason for importance of NLP. So reason for the importance of POS tagging in NLP. So POS tagging is given importance in LP because of these two reasons. The first reason, POS tagging converts raw text into structured, linguistically informed data. So it converts the raw text into a much more informed information. And the second step, it helps the computers to understand the grammatical structure as well as the meaning of the text. Okay, so because of these two reasons, POS tagging is given importance in NLP. Okay, so the first one, it transforms raw data into linguistically informed data, and the second important reason is it helps the computer to understand the structure as well as the contextual meaning of the text. Next, we are going to see the applications where POS tagging is employed. So now we are going to see the applications of POS tagging. So the first one is syntactical parsing, second one named entity recognition, then machine translation, information extraction, question answering system. So first application is syntactic parsing. So first application is syntactic parsing, where the tags are used to build the parse tree. So the parse tree helps in explaining the grammatical structure of the sentence. So the grammatical structure, whether it is a noun or a verb or a pronoun or determiner or preposition, that is explained by constructing a parse tree. So the construction of parse tree is called syntactic parsing. Okay. Next one, named entity recognition. The second application is named entity recognition, where The process is to identify proper names like person name, name of the location or organization name. So that is named entity recognition. So you are going to recognize an entity based on the name. Next one, machine translation. By correctly understanding the function of the word, POS tagging ensures the correct machine translation. Okay, so translation from one language to another language is properly done by understanding the word function. So this understanding is done with the help of POS tagging. Okay, so POS tagging ensures correct translation by understanding the word function. Next one, information extraction. POS tagging helps in extracting structured information from unstructured data. So it helps to extract the structured information from unstructured text. So the structured information here refers to the relationship between words. Okay, so the relationship between words. Then question answering system. The last application is question answering system. So POS tagging helps in identifying the question types and extracting the correct answer from text. So it helps in POS tagging helps in identifying the question and then extracting the correct answer for that question from the text. So these are all the applications of POS tagging. So the first application is syntactic parsing, where a parse tree is constructed. The second application is named entity recognition, where words are all recognized based on the names. Third application is machine translation. Fourth application is information extraction, and the last application is question answering system. So apart from these applications, POS tagging is also utilized in additional applications also. Okay, so here we have listed only few applications. So now see some of the tools used for POS tagging. So there are numerous tools available. So some of them are listed. So first one is NLTK. The tool is based on Python programming language. Next one Spacky. Spacky is also based on Python. Then Stanford POS Tagger is based on Java. TextBlob again a tool based on Python. And then OpenNLP based on Java. And then Unpass based on C++. So these are all some of the well-known programming tools used for POS tagging. Next we will see a tagging example. So we are going to see a step-by-step procedure programming example. Okay, so step-by-step procedure of POS tagging. The first step is install and import the necessary libraries. So for that, the command is pip install NLTK, then import NLTK. Step 2, download the necessary NLTK data and NLTK tokenizer and POS tagger resources. So the first step is install and import the necessary libraries. So the command is pip install NLTK and then import NLTK. The second step is download the necessary NLTK data, the NLTK tokenizer and POS tagger resources. So the command is so second step, download the necessary NLTK data, NLTK tokenizer, POS tagger resources. So the command is nltk.download punkt and then nltk.download average underscore perceptron underscore tagger. So these are the commands. So here punkt, it is a pre-timed it's a pre-trained tokenizer model and this is POS tagger. So you need a tagger as well as a model. So that pre-trained tokenizer model is P1KT and this average underscore perceptron underscore tagger is the POS tagger utilized. Third step is tokenize the sentence. So the third step is tokenize the sentence, where the sentence is broken into individual words called tokens. So consider the sentence. The quick brown fox jumps over the lazy dog. Okay, so this is the sentence given. This sentence is now converted into tokens. So the sentence is the quick brown fox jumps over the lazy dog. So this is going to be converted into tokens using the function word underscore tokenize. Okay, so it is present in the package NLTK. So tokens equal to NLTK dot word underscore tokenize sentence. Now we are going to print the tokens. So this word is splitted into tokens and it is stored in the variable tokens. Now if we are giving print tokens, the output will be the tokens present in the sentence. So for this third line, the output will be so the sentence is broken into tokens that will be given as an output. Okay, the fourth step is perform tagging. The next step, POS tagging is performed. So in order to perform POS tagging, they are using the inbuilt function POS underscore tag, for which the tokens is given as an input and the output will be stored in the variable POS underscore tags. So when we are going to print that POS underscore tags, we will get the word with this corresponding tag. So the output for the print POS tags will be like this. already we are having the tokens. So those tokens are all labeled or paired with the corresponding tags. So the is paired with determiner, quick is paired with adjective, brown is paired with adjective, fox is paired with noun, jumps is paired with verb, over with preposition, the with determiner, lazy with adjective, dog with noun, and the statement terminator with a terminator. Okay. So the last topic which we are going to see is the challenges of POS tagging. So first important challenge is ambiguity in words. So most of the words may have more than one meaning. So in order to resolve it, you need to know about the corresponding context where the word is used. So the first one is ambiguity in words. Second one, out of vocabulary data. So most of the time in social media, uh, we may use some words which may not be present in the vocabulary. So for those words, POS tagging is important. For those words, POS tagging is very much difficult. And that one is complex sentence structure. So if your sentence is very large, for that large or complex sentence, again tagging is very much difficult. And if your input text is very much informal or contains more amount of noise, then again tagging is difficult. And the last one is domain specific vocabulary. When you're having a text which is very much specific to a particular domain, labeling it to the corresponding tag is difficult. So these are all the challenges. So first one, ambiguity. So many words can function as multiple part of words. Under their circumstances, you need to resolve the ambiguity for the particular word. So in order to resolve it, you need to know about the context where the particular word is used. Second, and out of vocabulary words. Second one, out of vocabulary words. Taggers find it very much difficult to tag new words, misspelled words, as well as foreign words. Then complex sentence structure. So if your sentence is very much larger, so the difficulty involved in tagging is more. So if the subject and verb are far apart, which may occur in case of a large complex sentence, then POS tagging is difficult. So next one, the tagger or the algorithm, it finds it very much difficult to tag data from chat or SMS or social media. Most of the time taggers are trained on large corpora that we saw. So if the tagger is trained on formal text, it may find it difficult to tag data or text based on chat or SMS or based on social media language or grammatically incorrect text. Okay. So these taggers are all very much trained on formal text and they find it difficult to label informal text. Okay. And the last one is domain specific vocabulary. So generalized POS taggers may not work well for specific domain. So a generalized tagger may not work well for a specific domain like medicine, legal, or technological text. Okay. So generalized taggers may not work well for a specific domain specific text like medical, legal, or technological text. So this is all about the challenges. So in today's session we saw what is actually POS tagging, the definition, then what is a tagger, then types of tagger, then working steps of the tagger, then we saw about the reason why tagging is very much important, and then applications of tagger, tools used for tagging, and we saw coding example, then challenges of tagging. Okay, so that's all today. Thank you.